Good afternoon, one and all. Today, we are going to see about the problem in the three-phase sequence network by using the Zbus building algorithm. Zbus building algorithm and a few problems we solved in our earlier classes. The same thing here also we are going to implement, but we are going to calculate the sequence. We are going to draw the three-phase sequence network, and also we are going to find out the zero sequence bus impedance matrix. Take down this problem. Two synchronous machines are connected to the three-phase transformer to the transmission line as shown in the figure. That is, two machines are connected to a three-phase transformers to the transmission line as shown in the figure. The ratings and reactance of the machines and transformers are, so these are the ratings. Machine 1 and 2 rating are 100 MVA, 20 kilovolt, that is synchronous reactance XD double dash is equal to X1 and X1 is equal to X2 is equal to 20%. That means here you need to convert this reactance in terms of 100. So 20 divided by 100 is 0.2. So 0.2 J, like that you need to mention. Here X0 is equal to 4%. Next Xn is equal to 5%. Okay. So X0 is zero sequence reactance is 4% and the neutral reactance is 5%. Here transformer T1 and T2 the values are given. 100 MVA transformer and 20 bar 345, that is star to delta transformer in kilovolts. 20 bar 345 kilovolts star to delta transformer and having the reactance of 8% on chosen base of 100 MVA. So base MVA they have given as 100 MVA. Suppose in the problem, if not given means you just select according to the your values, like 100 MVA or 1 MVA. It depends on the values what, but generally many problems are given in the base of 100 MVA. That based on the problem you choose the base MVA if it is not given in the problem. On the chosen base of 100 MVA, 345 kilovolts in the transmission line circuit. The line reactance are X1 is equal to X2 is equal to 15% and zero sequence reactance are 50%. Draw each of three sequence network. We need to draw the sequence network and find the zero sequence bus impedance matrix. Zero sequence bus impedance matrix we need to find by means of Zbus building algorithm. So Zbus building algorithm, as I said, we have seen this in detail in our previous classes itself. Next, that figure also given in the problem. What about this figure? If you see this figure, it is like two machines are given. Here one machine, here one machine. Next, here the transformer is a delta to star rating transformer. That is for between the bus 1 and 2. Between the bus 3 and 4 is star to delta transformer is given. Here machine number 1, here machine number 2, here it is motor and it is grounded here. So here star to delta grounded. So you need to note down this transformer star to delta grounded. Here it is star to delta. Now first you need to draw the positive sequence network. Positive sequence network by the values. By the values you need to draw the positive sequence network. Here given in the problem here, this first machine is generator. The second machine is a motor. Okay, so here it is EG. So here mentioned as EG, EMF generated in the generated EG. So positive sequence. So here it is positive and negative terminal. Here motoring. Here EM, EMF generated in the motor. Here we are taking positive and negative. And having the generator reactance. So generated reactance 0.2. It is given in the problem. So yeah, it is given as 20%. No, so 20 divided by 100. So here it is 0.2 is the generator reactance. Next, here motor reacts for both the machines. For machine 1 and 2, it's the same reactance, 20%. So here also same J into 0.2, that is 20 divided by 100. So J into 0.2, it is the reactance. Then transformer reactance is 8%. Yeah, transformer reactance is 8%. So two transformers are there. So two transformers, transformer T and T1 and T2 are same reactance, that is 8%. So here 8 divided by 100, we are taking as 0.8. Sorry, 0.08. 0 divided by 100, no? So 0.08 G. So this is the reactance of this transformers, two transformers. So in between one transmission line is there. So transmission line also, they have given the transmission line reactance as X1 and X2 is equal to 15%. Transmission line reactance X1 and X2 is equal to 15% given in the problem. So simply they have given 15%. So 15 divided by 100. 15 divided by 100 is 0.15 G. So here we have drawn the positive sequence network. How to draw the negative sequence network? Negative sequence network, we don't have this that is generator EMF and all. So here you need to suppress. Already we have seen this basics, how to draw the positive sequence network, negative sequence network, and the zero sequence network for the like a generator, transformer and motor for the three sequence network for the yeah, here three-phase transformer. Ratings of the machines are given below, and the sequence network already we have seen. Already we have seen for the symmetrical components. Already we have seen the same thing as the same rules we are following here. For a negative sequence network, there won't be any this like voltage source might be mentioned. So simply as it is, you need to take. So what are the positive sequence network? Without this source, you need to draw the negative sequence network. So this is the negative sequence network. It's the same diagram for the same network for the positive sequence network. So here you need to neglect this voltage source for the negative sequence network. Coming to the zero sequence network, this also we have seen how to draw the like a zero sequence network for generator, transformer, transmission line. How to draw already we have seen. For zero sequence network, here you are having ZS. ZS is sequence impedance of that generator. Next, this 3 into Zn. 3 into Zn is the this is how you need to mention 3 into Zn for the generator for zero sequence. For the zero sequence, you need to mention like this. So 3 into Zn. So Zn, what is the Zn? That is given in the problem. Zs, sequence impedance, also given in the problem for the the sequence impedance for the the sequence impedance for the machines X0 is equal to 4%, Xn is equal to 5 percentage given in the problem itself. So here what we are doing is we are taking Zs is equal to 4%. So 4 divided by 100, that is 0.04 J. So sequence impedance equal to J into 0.04. Next, this thing Zn. Zn also given in the problem as 15%. Zn given in the problem as 15%. Sorry, Xn. Xn, that is a sequence reactance at the neutral point. That Xn also given in the problem as 5%. So here, what we need to do is here 3 into Zn. So 5% means 0.05. Okay, 0.05 divided by 100. So here 3 into ZN. So 0.05 into 3. So 3 into ZN means J into 0.15. Take your scientific calculator. Just calculate 0.05 into 3. So here you need to mention like 3 into ZN. So this is the formula. How this 3 into ZN comes now. You need to go back to my previous classes. Already I taught in a zero sequence network for generator. You need to mention like 3 into ZN. So here sequence impedance and as well as neutral impedance also you need to mention for zero sequence impedance diagram for a generator. Already I taught in the class. So here 3 into ZN. So it is J into 0.15. Next comes the transformer. So transformer, what is the type of the transformer? That also you need to see. Delta to star grounded. Delta to star grounded transformer. So that is this the first transformer. So if it is delta to star connected transformer, so here you need to open and delta means here you need to connect to the reference bus. That is the zero sequence diagram, network diagram we drawn for this delta to star grounded like already we have seen in our previous class. The same thing we are following here. Here the impedance is given for the transformer as 0.08. That is from the our previous positive sequence network and zero sequence network that is mentioned as J into 0.08. But here, how to connect the delta means here you need to connect that wire to, you need to open here and you need to connect that to ground. Okay, that is the formulation already we have seen in our previous classes. Next, here also two transformers are there. So here also star to delta. So star to delta means you need to open here. You need to open circuit here and not grounded. So only delta. Okay, delta. So here delta to star grounded. So delta to star grounded. So delta for delta you need to open circuit. For star grounded you need to connect one wire to the reference bus or to the ground. So here only see star to delta. So star to delta means here for delta you need to open. For star I think you need to mention as it is. So here what is the impedance of the this star to delta means J into 0.08. So J into 0.8 for delta you need to open here. So in between one transmission line also there. So transmission line no need, zero sequence network no need of anything. So the same thing as it is it will come. So J into 0.15 as it is J into 0.15 we are writing over here. Yeah, J into 0.15. Sorry, J into 0.15. For transmission line, I think it is for transmission line. Yeah, here it is mentioned in the problem X naught is equal to 50%. So 50 divided by 100 for transmission line, X naught is given as 50%. So 50 divided by 100 is J into 0.5. J into 0.5. So that is zero sequence reactance mentioned in the problem. So here with this problem data, we are taking that as J into 0.5 here. Whereas the positive sequence reactance that is given in the problem for transmission line for negative sequence reactance for mentioned in the problem as X1 is equal to X2 is equal to 15%. So that is for positive sequence and negative sequence. For zero sequence, it is mentioned as 50%. That is 0.5 J. So that's why here in zero sequence, we have mentioned as J into 0.5. So you need to very careful while drawing this positive sequence, negative sequence, and zero sequence. So you need to clearly see the problem data. If you miss this, automatically the whole problem goes wrong. So always see the problem data clearly. What is all mentioned? Say x1 is mentioned, x2 is mentioned, x0 is mentioned, xn is mentioned. Everything is mentioned in the problem itself. So you need to be very careful while drawing this zero sequence, positive sequence, and negative sequence. So for this is the network diagram for the zero sequence network. Now, what else asked in the problem? They asked to draw the three sequence network diagrams, and they asked to find out the zero sequence bus impedance matrix. Zero sequence bus impedance matrix. So from the zero sequence network, you need to formulate the bus impedance matrix by the bus building algorithm, not by ordinary method, by using the bus building algorithm. That is the rule. By using the bus building algorithm. It is clearly mentioned in the problem itself by using the bus building algorithm by means of the Zbus building algorithm. So bus building algorithm already we taught earlier itself. Now, so what is the first thing is that first bus you need to take. So first, say for example, this is the node 1, node 2, node 3, and node 4. So node 1, two elements are connected together. So two elements are connected in the series. So you need to add. So 0.15 plus 0.04 is nothing but 0.19. So this 1 cross 1 matrix, this is the reference bus, this is the new node. Like 1. Okay, this is the reference node, new node or new bus 1. In that, two elements are there that is connected in series. So we need to add. So 1 cross 1 matrix will come 0.19. So easily we wrote the 1 cross 1 matrix. Now, how to frame the next matrix? Here, same thing you need to write. Here it is open is there. So open is there. Next, you need to formulate the second bus. Here open is there, and here due to the open, you need to add 0 and 0 over here. Otherwise, if it is not open, if it is connected like this, here same elements you need to copy paste. But here it is open, so here you need to write 0, 0. Now, what is the second second node? So one element is connected. That is a 0.08, and it is connected to the reference bus, not to the old bus. It is connected to the reference bus. So here it is 0. Now only one element. So what you need to do? As it is, you need to write. That is 0.08. So if it is connected like this, you need to add this 0.19 plus 0.08. You need to add, but here no connection. So it is directly connected to reference bus. So here you no need to add. As it is, you need to write this element, that is J into 0.08. Now again, next third node or third bus. Okay, now one more element 0.5 J is added to the third bus that is connected to the previous old bus. So here what you do, just same matrix you need to write, whatever the matrix here, the same matrix you need to write over here. This J into 0.19, here 0, here 0, J into 0.08. And here, what all the elements is there? That same you need to copy paste. Here it is 0, here it is 0.08. Here printing mistake is there. Here it is 0.08. And here also the same thing you need to make transpose. Here also what you need to do is, here the same matrix you need to write over here, and you need to take this column matrix transpose. This column matrix you need to take transpose. Yeah, this column matrix, you need to take transpose, and same thing you need to write over here, this matrix. What is this This element is nothing but, here also printing mistake is there. Here it is, I think 5j will come, 0. J into 0.58j will come. Here, how this 0.058 will come in the sense, j into 0.08 plus, what is the new element added? What is the new element added? What is the new element added means, yeah, here, what is the new element? Previously it is 0.08. What is the new element added is j into 0.5. So j into this element is nothing but, this particular element is nothing but j into 0.08 plus j into 0.8. Sorry, j into 0.5. J into 0.5. This element is nothing but here, as I said, printing mistake is there. Na? J into 0.58. J into 0.58 will come. How this J into 0.58 will come in the sense, here, this element that is J into 0.08, J into 0.08 plus J into 0.5. Okay, this how j into 0.5 means, that is the new element added to the old bus. So j into 0.5 plus j into 0.08 is nothing but j into 0.58. So that element only we are writing over here. Understood? Now, what is the another element? J into 0.08. Again, j into 0.08. So here you see the same thing we also done here. J into 0.58. So here the same thing you need to copy paste. What are all the elements coming over here? You need to copy paste here. 0, j into 0.08, j into 0.08. So what are all the column matrix coming over here? You need to take transpose. You need to take transpose and you need to write over here. The same thing you need to write over here. This element, how it comes? This element, how it comes means, this element, that is j into 0.58 plus j into 0.58 plus the new element. What is the new element now? New element from the problem, from the data you see from the problem, that is 0.08. 0.08. This is 0. Okay, so if you add this, it will come, take your scientific calculator, you add this, it will come as j into 0.66. So that's why we have written over here. I hope you are clear up to this. Now, node A is a fictitious node, a fictitious internal node of the transformer 2. Node A is the fictitious internal node of the transformer 2. We have not calculated for the very high impedance branches representing open circuits. So here it is open circuit here. So we are not considering, we have not calculated the very high impedance branches representing the open circuit. So we remove the column and row of A, that is J into 0.8 per unit reactance in series with the open circuit, and does not affect the Zbus not, since it cannot carry current, because here this element, that is J into 0.08, we are not considering because here it is open, and also this impedance is very, very lesser. This impedance is very, very lesser, and we have not calculated for very high impedance branches representing open circuit. So we remove this column and row. So what we are doing is, we are removing this. We are not taking this column A. We are not taking this column A and row A. Just we are neglecting this. Okay, just we are neglecting this, and simply we are writing it because here you see only this 0.08 per unit reactance only in the series with the open circuit, and it does not affect the Zbus not, since it does not carry current. Okay, so that's why this particular column and row we are removing. That is fictitious node A. We are removing. So now this Zbus not becomes like this. Now this Zbus not becomes like this. Now again, if you go back to your previous like impedance zero sequence network. So here you see now again what happens here again this two are in series. This two are in series, that is j into 0.4 plus here it is open after that fourth node. Here it is j into 0.04 and here it is 0.15 is there. Now what we need to do is now you need to consider these elements to the fourth node. Consider these elements to the fourth node, that is add j into 0.19. How is j into 0.19 comes means here we are adding, that is j into 0.04 plus j into 0.15. So it is j into 0.19 is coming. So here we are adding, and again bus 4 we are rewriting this bus 4 here. Okay, bus 4 here. The same matrix you need to copy paste. So previously it is open, and also it is grounded. Previous bus is grounded and it is open here. So here all 0, here also 0. Now this element alone will come because that is open. So no need of adding with this. The same element, whatever is there, because that is j into 0.19 is there. The same thing here we are writing. J into 0.19 we are writing. The zeros, this is the Zbus 0. The zeros in Zbus shows that zero sequence current is injected into the bus 1 or bus 4 cannot cause voltage at other buses because of the open circuit. As I said, due to the open circuit, so and also zero sequence current injected into bus 1 or bus 4 cannot cause voltage, cannot cause the voltage at other buses because due to the open circuit introduced by the delta and star connected transformer. So here we are taking as zeros, and here also we are taking as zeros, and whatever the series element we are getting. So two elements are there, j into 0.15 and j into 0.04, that you need to add, and finally j into 0.9 you need to take over here. So this is the Zbus not for the 4 buses.